So first of all, I wanted to thank Enjoy the Music. They sponsored the seminars for Rocky Mountain Audio Fest. So thanks to Enjoy the Music, enjoythemusic.com for that. So today's talk that I'm giving is called Why Audio Measurements Matter and Why They Sometimes Don't. It's really mostly about consumer-facing audio measurements, which are becoming something that audio consumers in the high end are pretty much demanding almost. They want to see them. And it's something I hope the manufacturers do more of. But first I'll tell you who I am. I'm Jude Mansilla. I'm the founder of a website called Headphone.org. It's a website and forum dedicated to the coverage and discussion of premium headphone audio. We were founded in 2001. We reach over 50 million unique visitors a year. It's probably one of the more trafficked hi-fi sites, but our focus is headphones. Our audience is younger, which is noteworthy because I'm 48 years old. Three-quarters of our audience is younger than me, so I'm old in our group. We do trade shows, headphone audio trade shows called CanJam. So there's one here, obviously, CanJam, Rocky Mountain Audio Fest, and then we do New York, Singapore, Los Angeles, London, and we just added Shanghai this year. So again, the topic is really consumer-facing measurements, and I really hope that all of the companies, or certainly hopefully most of the companies who are making gear in this building that we're listening to, we hope that they're testing and measuring their gear. I'd like to believe that most are. But the measurements that they do rarely see the public light of day. We don't see them. And I've tried to encourage the manufacturers that we deal with at Head.Fi to share their measurements because the consumers want to see them. And they want to see them so much that if they can't get them, they're gonna make them themselves and build the rigs to do it. And thinking about all of this, these consumer-facing audio measurements from manufacturers, which a few do provide them. Benchmark is one. Benchmark Media provides them. Core Electronics. I'll show you some examples later. I think Shit Audio just started providing them with their new products, downloadable AP reports on the spec pages. But thinking about what consumer-facing manufacturer-provided measurements sometimes used to be like in the old days. My parents had a Fisher stereo system, and on the speakers were frequency response measurements. And so I tried to find the exact system, but I couldn't find it. I searched the web, and I found this, and it reminded me a lot of the old system. I want you to pay attention to the model number, because this is what we saw a lot of, and then on a lot of headphone boxes and things like that, or speakers, you'd see a lot of shockingly flat measurements. So that's the system frequency response of whatever the STV-873 is. And there's the STV-816, there's a system frequency response. There's the STV-853, starting to look familiar. The 752, no model there. But it's amazing over the years and over the models, they've been very consistent. The 893. So they're doing quite well. Fisher was very good at arriving at their target response. 723. Oh, we can keep going. There's the 830. So I stopped there, but I bet you there were more. I think by now you realize that frequency response is looking awfully familiar. So either Fisher was uncannily good at arriving at it with their systems. We don't really know what system they're talking about because a lot of times these came in rack systems. So do they mean the entire system or just the speaker system? I don't know. But even if we give them the benefit of the doubt and say that that was an actual measurement at some point, like based on a real measurement, what was it a measurement of? You know, was it the speaker? And if it was, how was it made? If it was the system, how was it made? So we don't really know. But I thought that was interesting. So as far as I go, I never thought I'd be doing measurements myself. I've been reading. I was the 12-year-old kid who didn't buy car magazines. I subscribed to Stereo Review. For anybody old enough to remember Stereo Review, the late Julian Hirsch was the publisher and editor. And he had Hirsch Hauck Laboratories, and he did measurements. And that's the only reason at that age I'd even know what a frequency response measurement was. But I probably believed that to be true at the time, right? Because it was there. It was on the speaker. I probably believed it to be true. And then, of course, there's John Atkinson, who's still one of my standards for electronic measurements because, you know, I like his amp and DAC measurements. And Paul Miller, who I had dinner with last night, and from Hi-Fi News, and I think I probably pestered him for 2-3 straight hours to talk about measurements. I wish he could have been here. Tyler Hertzens, of course, retired now, of Interfidelity. He was the first that I knew of to do headphone measurements, which is kind of what we do more of than anything, because headphones are our specialty as far as what we cover. And if Tile didn't do those lab type measurements for consumers, I don't know that we'd ever done it. In fact, I can say almost certainly we wouldn't have. But he did those. I don't know if Brent Butterworth is here, but he does them as well, as does Keith Howard. But as interested as I've been in audio measurements, I never thought I'd do them myself. But then about 4 years ago, Paul Barton came to visit us at Headphone HQ. I just realized how morbid that picture looks. He's still alive. That looks very memorial-like with that cloudy look. No, Paul's just a little under the weather and couldn't make it because I wish he could have been here. Because he's kind of been one of my measurement mentors. He's very much alive. So he came to our office and he brought one of these. It's a Gross 43AG ear and cheek simulator. He set it up in minutes. And we have like hundreds of headphones at Headphone HQ, so he was looking around and saying, you know, you should do headphone measurements. This would be a really nice place to do headphone measurements. Whipped that thing out, had it out in 10 minutes, and we were doing headphone measurements. So he gave me the contact information for Gross. I think I called him a couple days later, and we ordered one of these. That's a Gross 45CA, otherwise known as Thor's hammer, or the hammer. If you take that Focal Utopia off it, there's a pinna under there. And it has it's essentially two of what Paul brought in a headlight fixture in terms of head height and head width, so that we can measure both drivers at the same time, and also get a nice caliper pressure that correlates to an average human head width. Obviously the cheeks aren't very realistic, but it's great for workflow. And I'll explain later what ear simulators are, because I think there's kind of a misconception about what ear simulators are. But enthusiast-generated audio measurements are kind of where, certainly with headphone measurements, where most of the headphone measurements you're going to see are coming from. On the electronic side, not as much. It's harder to cobble something together from bits and pieces that you can measure a DAC with or an amp with. But you can cobble some stuff together to try to measure microphones and things, to measure speakers and headphones. So you'll see a lot of enthusiast-generated headphone measurements. In fact, I think it's safe to say most of the ones you'll see on the web are generated with DIY systems. But electronics do get measured sometimes. This was measured by an enthusiast on a forum. It's a DAC. It's a USB DAC. It's using an inexpensive analyzer. It's a nice analyzer from what I know. But is it the analyzer you'd use to measure a lot of the modern DACs? Probably not. I think it's a $400 or $500 analyzer. That's a USB DAC. I think it's sub $100. It's by Grace Design. They do nice work. And I saw that measurement, and we'd measured it as well. We used the exact same, because I saw the parameters over there on the top left. So we did the same thing, because I was talking to the Grace team about the DAC, and so I knew that was probably a little bit high on floor. And so we measured it. So the pink measurement would be this one, and the blue one's the one we did. We used an audio precision analyzer, and so we measured it. And I know that the analyzer we're using can get to the bottom of that DAC. And so you can see there's about a 35 dB difference on the floor. I mean, that might not sound super significant, but if you're familiar with dB, you know that's pretty significant. The DAC designer would certainly say it's significant. I don't think he'd want to see the upper one representing his DAC. 35 dB in volts, I think if you had 1,000 millivolts and you said reduce it, 35 dB, I think we're down to 17.8 millivolts or something like that. So it's significant when you look at it that way. But some manufacturers, like I said, do put out measurements. I wish more would put out measurements of their own. I think it's a great idea for them. Because I talked to a lot of manufacturers, and some of them actually complain about what happens out in the community with respect to measurements of their gear not being representative of how they would actually measure. And I actually gave a presentation about this at ALMA, which is at their annual conference, the International Association of Loudspeaker Manufacturing Acoustics, in January, just actually asking the manufacturers to publish their measurements. So there's in CanJam over there is an in-ear monitor maker. I won't say the name of the company. And I was talking to one of their principal engineers, and they don't put out their measurements, or they didn't. And they worked 1.5 years on an in-ear monitor that they were quite proud of. And then they sent some preview units out. And somebody measured it on a DIY rig. And it didn't turn out very well. Wasn't at all representative of how it sounded. Certainly wasn't representative of how it measured either. And so he was complaining to me. You know, we worked a year and a half on that thing, and then the first impression is this measurement that goes out that looks nothing like it's supposed to measure. It doesn't look anything like how it sounds. I said, so then put out your own measurement. He said, we don't do that. You know, our measurements we keep internal. I said, well, that's your problem. You should put them out. And you should put them out first. That way you can get the first word. Because I'm going to show you later, these measurements have a huge effect on opinion, on subjective opinion even. I actually look at some headphones when they're released, and I say that there are pre-measurement subjective impressions and post-measurement subjective impressions. But so he did put it out, but you know, first impressions are kind of hard to get back. You can, but it's kind of hard. So I said, get in front of it. So some companies do. Again, I mentioned Chord Electronics. So on Head.Fi, Rob Watts, who designs Chord's DACs, he has his own area on Head.Fi, a little blog forum area called Watts Up, and he probably posts way more than Chord wants him to, because he tells like us their product plans for like the next 2 years. I don't know that they want him to do that, but he does it. And he posts the measurements. I don't know how much they want him to show, but he posts them anyway. I don't think he does it to get ahead of anything. I think he just does it because he loves talking about this stuff. So that's, I think, a Chord Hugo too. And again, it's not so much you know, anything specific about the measurement I'm showing you, just that he's posting his own measurements. So I think more manufacturers should do that. So anyways, but again, as I said, on the enthusiast side, headphone measurements are what we see more of, just because it's easier to cobble together something that can measure a headphone. But that does introduce some issues, because when you're measuring electronics, oh, did I lose that? When you're measuring electronics, you know, it's a bit more of a direct hookup, and it doesn't mean you don't have to be careful how you hook it up, but when you start measuring headphones or speakers, you're introducing now a mechanical component to it, and that can be pretty complex, and that can add a lot of complexity to it, because then you have to talk about the precision of the actual mechanical components that you're using to measure. And there's nothing wrong with DIYers doing measurements, I don't think. Of course, I think it's great, because if you care enough to put something together to measure a headphone, it means you really care. And if you're modifying headphones, you're a DIYer, and you want to see what the effect is of your measurement. I mean, it's better to have something than nothing. I think where it gets a little bit hairy is when you start putting measurements out as an absolute measurement to a forum that reaches 15 million people a year, or other forums, or Reddit, right? I mean, and so that's a lot of people being reached, probably tens of thousands over time, hundreds of thousands, and if it's really, really talked about, it can, you know, over a couple of years even hit over 1 million people. So here's an example of a measurement. This is a measurement of a Sony MDR Z1R that was posted. And the thing about it is, if you're not used to looking at measurements, and you see this measurement, and you don't know how the headphone sounds, you've never seen it before, or heard it before, you know, there's nothing necessarily, if you don't ask the right questions, to make you think that it's any different from this one, which I measured. I'll show you how I measure headphones later in this presentation, but so you got this one, and then you have this one. What makes this one any more definitive than this one if you know nothing of the headphone? I don't really think not much at all, so you have to kind of discuss what and how you do the measurements and what you're using to measure with. So this measurement was posted, and there was no narrative about how it was made, so we didn't really know how it was made. And then eventually he did post this comment. Oh, so I'm going to show you how we do the measurements, and we add our logo to it because when we want our measurements to be identifiable when we do them. And we do work with Gross and Audio Precision gear, and we work with them closely. We do measurements, and they've actually helped a lot in mentoring us as well over the last 3-4 years. But here's the comment that was made about the measurement. So I made the last measurement. That spike is much bigger than others. I would not necessarily trust mine completely. My measurement rig is a piece of leather and some felt tapped to a broken lamp. But it does seem relatively accurate for most measurements. Now, if you're familiar with the MDR Z1R, I would assert that doesn't look like it sounds. Also, just the shape of it suggests to me that he used some sort of compensation, and that's like a whole nother seminar we could have. Because compensations are like the Wild West. It's like people are just using whatever the hell they want to use for compensations. And maybe we could do a seminar about that, it'd be fun. But that's not how it sounds to me. I found a picture, I think that's the rig. But once again, I'm not trying to make fun of this guy because frankly, he took the time to put that together to measure a headphone. The problem is, I think, a little bit, though, is that if it's put out as an absolute measurement, I don't think that's representative of the headphone. I think this is version 2 of the system. And the next several DIY systems probably constitute where most of the audio measurements, headphone measurements you see online come from. And so here's more DIY systems. And then, so you'll see there's a lot of things I have in common. Now that's an HD 600 being tortured, because if you look at it, it's obviously being stretched way beyond what a normal head width would be. So the caliper pressure could nowhere be accurate, right? I mean, that's being tortured. And then you'll see there's that foam there around the mic, and you'll see that a lot of the rigs have that, and I'll explain why. There's another one. There's another one. That's a 650. That's probably being stretched quite a bit wider than would be normal. And also you can see the angle that the yokes are being pulled in wouldn't be representative of how it's worn. That can change the angle to the mic. But given how the mics are being situated anyway, I'm not sure how much that would matter. This one has generated probably a great deal of measurements you might have seen online. And that would be version 2 of it. And in the instructions for how to make this one, I think, is where that foam comes in and the felt. It says, in the middle of a foam layer, a piece of felt about the size of an ear. Without this piece, I found measurements too ringy. Covered completely with felt, I found measurements too damp. So there's a bit of dead reckoning going on. And then it says, the felt the size of an ear also serves another function, proper measurement of supraorals that rest on the ear. Now, I think that's a bit of a stretch, because I think a flat piece of felt or rubber would be not in any way representative, volumetrically or otherwise, of a pinna, especially for a supraoral, which is an on-the-ear headphone, one that rests on your ear. So I don't think that would really be representative at all of getting a proper fit of a supraoral. So now we're going to go back to, so we're using this. Actually, we're using 2 different fixtures. We're using this and then a more anthropometric, or it looks more like a man, the Keymar. So, but this is one of our main fixtures, and in it is obviously 2 ear simulators. And I think the misconception with ear simulators is that it's essentially a microphone pushed up into a pinna that looks human-like. But it's a lot more than that. So an ear simulator it's an apparatus that connects the device under test to a microphone in a way to load it such that it would face on your head, like when you put it on an ear, in the same manner as when you wear it. And it's actually a more complex device than just putting a microphone into a pinna. This is a typical ear simulator, the kind you might see from Brulin Kerr or from Gras. It's a pretty complex and very precise piece of kit. There's a multi-volume coupler over there on the left, and the microphone goes into the bottom that you'll see there. And then this video shows, I just found this on YouTube. It gives you a better idea of how it all kind of fits together. So you'll see here, that's the human ear. And then the ear simulator, there you go. So that's what it's doing. So the ear simulator is a little more complicated than just simply pushing a mic into a pinna, because you're trying to simulate the load, the input and transfer impedance of the human hearing system, so that when you put the headphone on or in the ear, it's facing a load as it would on a human. And it's not just any microphone that you put in these. The measurement microphones, the kind by Brulin Kerr, by Gras, are very, very precise pieces of kit. It's not just any kind of microphone. You will not find them at Guitar Center or Sweetwater, most likely. This is a very specific type of thing. Typically a 1/2-inch microphone. What this table is showing is the diaphragm's movement when it's facing pressure. 1 Pascal or 94 decibels of pressure is 5 nanometers is the displacement of the diaphragm, which is about 50 angstrom. An angstrom is 1/100 millionth of a centimeter, or about 1/4 billionth of an inch, if I did my math correctly. And it's used to measure interatomic distances. So I think 1 angstrom would be equivalent to, I think it was a fluorine atom or something like that. So the diameter of an atom. At 60 decibels, remembering that dB is log scale, you're down to 0.02 Pascal or 60 dB, and that's a level that we'll measure, obviously. 60 dB is relevant. And that diaphragm is moving 1 angstrom, so it's moving the diameter of an atom. At 40 dB, we're down at 0.002 Pascal, and it's moving 1/10 of an angstrom. Now, when you're talking about distances that small, or things that small, I mean, it helps to scale it. So I have a ridiculous scaling example. If you were to take a 1/2-inch measurement microphone and scale its diaphragm to the diameter of the Earth, so 12,500 kilometers, the diaphragm thickness would be 2 kilometers thick, and its distance from the backplate would be 20 kilometers. The scaled up 0.1 angstrom, so at 40 dB, would scale to 10 millimeters of displacement. So you're talking about a worldwide, an Earth-wide diaphragm that's 2 kilometers thick, moving 1 centimeter to measure 40 dB. So it's a very precise piece of kit. But that does raise a very interesting question. Do we really need this level of precision, or is it just silly? And I would assert that you do need this level of precision, but we'll get to that in a second. So it's not just any mic. So we started with the Gras, like I said, then we added an APX 555, an audio precision APX 555, because we were using fuzz measure on the Mac, which is a nice piece of software, but then we decided we wanted to get, okay, once you start measuring, you want to keep going. So that's an APX 555 on the bottom. With it, I think we can measure any DAC on the market right now. I think we can get the full measure of any DAC. There might be something out there I'm not aware of. And we can certainly measure anything acoustically with that as well. And then there's the APX 1701 on top. That's a transducer test interface. That's a fancy name for a lab-grade amplifier. It can drive headphones and speakers up to 100 watts a channel, and it communicates with the software and the analyzer. But because it has fixed 20 dB gain, if I have an in-ear monitor that requires only 3.5 millivolts to get to 90 dB SPL at 1K, with a fixed 20 dB gain, then it's asking the analyzer for 0.035 millivolts, which isn't really ideal, even for a 555. So THX built this for us. I was just kind of joking. I saw them last year here at RMAF, and I said, your your AAA, 888 amp, which I measured a test board of, measures so well. It was the lowest distortion, lowest noise, anything I'd ever measured, that if you made one in unity gain, that would be a great sensitive headphone measurement amp. So they made one for us. I didn't expect that, and so several months later they said, hey, look what we made, and they sent it to us, and so we're using that for sensitive in-ears and sensitive headphones. But the one thing it doesn't have that this has current sense so that we can do impedance measurements. This one doesn't have it, so we use this for sensitive headphones. It's very, very nice for that. And then, of course, like I said, it's kind of a rabbit hole. You just keep going further down, and so we're like, I want to do higher order distortion measurements. And to do that, you're getting down into nanovolt levels of voltage. And so obviously we can't afford a proper anechoic chamber. That would be, 6, 7 figures. Don't have that kind of budget. I drive a Honda Fit. I'd probably upgrade my car before I did that. But anyways, so we got this. A company in California called Herzan built this for us. We bought this from them. They shipped it. It weighs about 1,300 pounds. 11 layers of varying density in the walls and doors, and the acoustic foam inside. And it's on a pneumatic platform that isolates ground vibration down to 4 hertz. Obviously, physics is physics, so low frequencies coming through are going to get through, but there's some attenuation, of course. Weighs like 1,300 pounds, so it's not a joy to move, but it is on wheels. And there it is. Cable ports are sealed. And yeah, so there's the list of everything that the system currently has. The APX 555, 1701 Gras. Anyway, so now we're considering looking at Brulin Care just announced a new head not that long ago called the 5128. We're probably going to test with that at some point to see if that's something that we would want to use. Because the idea here is we don't manufacture anything, and so sometimes when the standards change, it's a bit of a pain for the manufacturers, because I was talking to a headphone manufacturer and I asked him what he thought about the new heads, and because we're using some of the newer ears, the anthropometric ears and canals and stuff. And they said, well, it's nice, but we have 20 years of data for our products that we're using the straight 6711 standard. So it's kind of a pain. Well, we don't make anything, so for us, we just want to have the best tools available for the job. So we're going to evaluate the 5128 probably at some point soon. So let's look at DIY headphone measurements where we have examples where they were done on DIY, what I'm seeing, what you might be seeing, versus what we measured. So this was a measurement of a Sennheiser HD820. I'm colorblind, so let me see what color. HD820 is green. and the HD800 is red, and the HD800S is blue. So the HD820, for those of you not familiar, is a closed-back headphone that's kind of a closed-back version of the HD800S, which would be the blue one. And if you watch the lead engineer's talk on Head.Fi, which we videotaped at CanJam New York, he explains the design and the engineering of this headphone. And one of the things he mentions is, once you get into the treble range, the treble is very similar to the HD800S. But you can see here it really isn't on this measurement. And part of the problem is the need to model the acoustic impedance of the human hearing system becomes increasingly important the closer you get to the ears, and the higher the acoustic impedance of the system, the circuit. So a closed headphone, for example, it'd be more important to model the acoustic impedance of the hearing system more than with an open. And so what's happening here is, I've seen this rig, there's no ear simulator on it. And so the 820 doesn't measure the way that it's Sennheiser, the way they described it. So we measured it, and that's what we got. So it's a Sennheiser HD820 in the dark, the darkest, boldest line. And you can see it lines up pretty well in the upper treble range with the HD800S. And you might look at that and say, wow, look, the canal resonance and everything lines up. That's pretty convenient. Is that going to do that for every headphone? And the answer is no. It's rather unpredictable, so you can't simply compensate. So you couldn't compensate, you couldn't take this green measurement and simply compensate that to look like ours. You can do it, and it would look like ours for that headphone. But the moment you put another headphone on it, it won't look the same anymore. So now he measures another headphone, I measure another headphone. It will not look the same. And the canal resonance is lining up because that's the Sennheiser HD800, HD820, HD800S. They have the same driver, except the HD800S and the 820 have Helmholtz resonators in the middle. But this is the same driver, the diaphragm. And they're pretty much at the same angle and same distance in a similar enclosure in terms of size, obviously the 820 being closed. And so you're going to see these similarities. So in case you're wondering, like, would we get that? Would you get that kind of overlay if you measured another headphone on it? And that's where I'm saying you can't, no, it's not really that predictable. So here's a MDR-Z1R. That's that measurement I showed you earlier, but now it's dotted. And you can see no matter how I normalize this measurement, you're never going to get the canal resonances to line up over here, because the similarities aren't the same as with its cohorts, its open back siblings. But because this one didn't model the acoustic impedance the way that they're doing it at Sennheiser, the measurement doesn't look like how they engineered it. And that one does, because I actually sent this to Sennheiser and said, does this look like what you guys are getting? And they said yes. Here's another one that just happened recently on the forums. It's a Biodynamic Zalento, which I believe is out there at the Biodynamic exhibit. It's a nice in-ear monitor, but not so nice in this measurement. So even if you're not familiar with the Zalento, but if you are familiar with an Etymotic ER4XR, you can see that doesn't look like it either. But this was posted on the forums, and there was commentary about it from somebody, I don't think the guy who actually made the measurement, because these measurements do have an influence on subjective opinion. He said, for their mid-range in particular, the difference between Zalento's sub-bass and its upper mids is at most 30 dB with the bass as the loudest. The curve cannot show everything, but on this occasion it can help to explain why Zalento is, as I've said, intrinsically flawed. Therefore, the Zalento is in fact omitting many details that should exist and distorting even more. This, instead of simply its bass, is what I meant by intrinsically flawed. So I hadn't measured this yet, but we have a Zalento, and then the Zalento has a sister model that they made for Eskel and Kern Biodynamic called the AKT8IE. It's a very similar headphone. So we measured both, and this is what we got. So I sent this to Biodynamic, and I asked them, I sent them both measurements. And they said, I don't know what's going on with the first measurement, but what you're getting is what we're getting. And so that's the Zalento. So if you look at what he's talking about, and if you see the drop-off from the bass, if you just do the math, he's getting tremendous, I mean, there's just a lot going on that I'm not sure what's going on. And then the ER4XR, again, I'm not sure what's going on there. And so again, now you're talking about an example where modeling the impedance is going to become increasingly important, because now you're talking about getting closer to the ear because it's going in the ear, and it's closed. So now you're talking about where modeling impedance is going to matter the most, perhaps. Oh, and that distortion comment he made, it just happened that both of these have among the lowest total harmonic distortion we have ever measured in a headphone. That is low, really low. And if you go back to that comment, he talks about distorting even more. And as far as just at least the literal definition of distortion, clearly this is a very, very low distortion in your monitor. For whatever that means, we can debate that all day long as far as audibility. I'm just saying that it's clearly not distorting. It's actually distorting less than anything we pretty much ever measured. So getting back to, you never get a second chance to make a first impression. You know, I mean, Biodynamic never published that measurement. But imagine they had, right? Imagine on their website they had a measurement of the Biodynamic Zolento. I mean, that's what they should do. It should just be there. They measure them. I mean, when they can look at my measurement, compare it to their measurement, and say, yeah, that's what it looks like. I mean, why aren't they just putting it out? I don't understand. And so I'm asking the companies to do this, and some of them are considering it. I can't mention any specific companies, but I think you might see some measurements coming out from a couple of headphone companies, because they do deal with this issue of DIY measurements going out there that look nothing like what they should, and so and it's happening more and more. And these are just examples of more measurements that we've done. This is the Focal LX Illyria Utopia. Now, at the bottom, anytime we post a measurement, we always list what we measure with, because we do have a few different measurement configurations that we use. So again, we have a Gross 45 EV12 and a Gross 45 CA. You're going to get slightly different measurements between both. So we've had people say, you know, gosh, you've done 3 different Focal Utopia measurements. They're slightly different. One a little more different than the other two, and the reason is we had 3 different configurations we use, because we're going to, again, use what we can. We upgraded the original ears, pinna, and simulator on the 45 CA. This one's really interesting. Now, this is a compensated one. I'm not big on compensation, even though we only have ever used one compensation curve. We've used the KEMAR DF diffuse field compensation curve. A lot of the guys that are measuring are applying compensation curves, not even understanding what it means. I mean, we apply the compensation curve. Well, we've done it with the 45 CA using the KEMAR DF, but the KEMAR diffuse field compensation curve was made on a KEMAR diffuse field environment, so it's meaningful to that fixture. And so, anyways, we applied it here. So that one's compensated. I think the rest weren't compensated, but it's the one I had handy. And there's something interesting. You'll see that 9K diff. That's a resonance thing. You'll see that with a lot of headphones on the measurement systems. I was talking to Dan Wiggins at Periodic Audio about it, and he said, boy, if I don't see something like that, I question the system. You expect to see these kinds of things. And so we decided to do a simple experiment at the office with the HD650, actually. That's the dashed one. Because we noticed they had this deep notch at 9K. And so we swept it. We'd do a sweep. I wore the headphone, and one of my colleagues, Brian, would wear the headphone. And we would sweep, and then we would hit a space bar when it went down. I said, wait till it goes down, and then when it starts going back up, and it's gonna happen very quickly, hit the space bar. So we would do this like 5-6 times, so that we can kind of know what to expect, and then know where the trough was. And so for him, he was getting it at 8. So I would guess that for him, the distance between the diaphragm and his eardrum was probably further than the KEMARs. We did mine, and I was at about 9.1K, so within 100 hertz of KEMAR. So now we took an 8K sine signal, and sine signals in that range are obviously really unpleasant to listen to. And 8K for me we're all pretty much sensitive at 8K, but with this headphone I play 8K, and it was like a drill being pushed through my head. And so I just said, okay, that's uncomfortable, so I stopped. We left the level the same, and I gave it to Brian, because at 8K it should be quieter for him. So he did it at 8K, and he said, I wouldn't want to listen to it all day, but it's kind of muted. So we went to 8.5. He said it's getting louder. We got to 9. He says louder. 9.5. He didn't like it. So okay. Then we did me. Of course, at 8, I didn't like it at all. 9, it was muted for me. What's interesting about that? It's a pretty crude test. But what's interesting about that is that you have the same headphone, the same stimuli, same levels, everything. 2 different guys wearing it, and vastly different experiences. But yet we'll all get on a forum and argue about who's deaf because he thinks the headphones break. Because we do have different experiences, independent of preference. That's the cool thing about that. It was independent of preference, right? It was just about a physical difference. So here's how we measure the headphones, and I don't want to go too long on this, but I think it's important that you ask the question when you see a measurement, how did you do it? And what did you do it with? I mean, you should expect to see how it's done. Because positioning that headphone over the ears is, for example, a big deal. Where it is relative to the mic. Oh, by the way, I want to show you, this is our first configuration. Those pinna are still what most people are using, even with the lab type systems. you know, they weren't made to measure headphones. They were like hearing aids and telecom stuff, and so they're stiff. And you can see that this supraoral or on the ear Odyssey sign isn't compressing it. If you feel your pinna, they compress to your head very, very readily, and that obviously isn't. And so we then updated it to the anthropometric pinna, and you can see it's a new pinna that they released, I think, over a year ago, a year and a half, 2 years ago. And you can see it compresses very readily. And this is the sign on the Keymar with that pinna, and you can see, and we can get a flat measurement to 10 hertz with that. So we're getting the seal. And then here's just positioning the headphone. And what this shows is the positions where we're still getting a seal. And you can see that on a more anatomically correct head, you're not, you know, you're pretty limited, because if you go too far back, it's going to fall off the back of the head, you lose your seal. You go too far forward, you're going to lose the seal. Too far down here at the nape of the neck, you're going to lose your seal. But when you use a fixture like this, unfortunately, it's much more easy to get a seal. So you have to kind of know where the realistic positions are. Too far back, like there, it's not a good place. That right there, not good. It's not realistic. So it's understanding where on this fixture would represent a more realistic measurement. And then here we use real-time instrumentation. So we certainly didn't invent using a square wave. Tyler Hertzens used square wave. Christopher Struck uses square wave. So a lot of the companies we talked to, they use square waves to do placement. But we were like, hey, wait a second. We have this real-time FFT spectrum view over on the right side. And square waves have a lot of harmonic energy, even all the way out to 20K. We can detect it. So if we monitor that, we can have some semblance of a frequency response on the high end where it gets really dodgy, and we want to get some symmetry, right? And so now we limit that from 2K to 20K, and so we can focus on the higher end frequencies. And what we do, and we've changed this since, is we then move around the headphones and in real time watch for symmetry here. And I'm going to run out of time, so I'm going to keep going. And eventually we get that symmetry if the headphone allows it. Some headphones just simply don't allow it. The more cushy the ear pads, like if they're really pillowy, it can be difficult to get symmetry. But you can see here, this is an HD800S. We're going to get pretty darn good symmetry here. So on this seating, we're like, all right, we're good. We're going to get good symmetry there. We're going to run the sweep. So we run the sweep. And this doesn't take very long to do, but it's a nice thing to be able to do, is to use that. And there's the sweep. So there's one seating. So the question again is this kind of precision needed? I guess I think so, because these headphones, like an 800S or an 800, or Focal's headphones, these things are built almost like lab gear. They're built to incredibly tight tolerances. I mean, I don't think quite to the measurement mic tolerances, but they're built to incredible tolerances. Here's an interesting thing that we saw with the HD800. So this is serial number 00279. This is one of the first, if not, yeah, I think this is one of the first, or the first HD800 into the country in 2009. And it was the 79th unit ever made. And we were doing a test. Some people on F.Y.I might remember we were doing these tests with 40 hertz sine waves. You see the second harmonic at 80, the third at 120. And here's the interesting thing. That's left channel, there's right. So that's 90 dB SPL at 40 hertz. Let me do that again. Left, right. And it took 220.4 millivolts to get the 90 dB at 40 hertz. So here's serial number 45721, a much more recent unit. This would be a last year manufacturer unit. And I think this is one we bought at retail. And there's right. Left, right. And that took 174.5 millivolts. Again, the other one took 220.4. And yet we're only setting level on one channel. So if one of the other channels was less sensitive or more sensitive than the other, they wouldn't line up. One would be higher than the other, certainly at the fundamental, at 40 hertz. There's 45721 at 100 dB SPL, and look at that. They both go up in distortion the same. These things are built to incredibly tight tolerances. That's incredible, I think. Oh, and that took, that won't matter as much. That's 551 millivolts because it's 100. This is another one, 45957, 201 millivolts in the right. I mean, that's an incredible amount of matching. By the way, by the time you're looking at the harmonics down around here, I mean, you're looking at nanovolts. So a lot of people don't understand. I mean, these are like double-digit nanovolts. And for those of you who don't know, a nanovolt's a billionth of a volt. Imagine the decimal places on your multimeter going that far. I mean, it's an incredibly tiny value. And so you can see we're getting harmonics and other things and other artifacts above the noise. But without isolation, I don't think we'd be able to do that, actually. And you'll see some measurements that are out there that will show harmonic 3, harmonic 4, harmonic 5, these distortion product measurements. But chances are, at that high harmonic, they're almost certainly measuring noise. In the FFT bin, there's almost certainly just noise left there. So I would say that the precision is certainly warranted if you want to get the full measure of the headphone. If you're going to publish a measurement for thousands, hundreds of thousands of people to see, I think you should try to. Now, mind you, it's difficult because it's expensive and tedious, but to measure that many headphones, and it's not like people do this for, too many people can do this for a living. But so I think it's warranted. And anyways, I just realized I'm running out of time, and that's the presentation. So I do think it matters. And I'll leave it to you for any questions now, if anybody has any. There's a question over there.
So it seems like you're pretty open with all these measurements, and I'm curious if you would ever publish the raw data so that someone could say, hey, say they like the sound of an Eddie-modic earphone.
Okay.
Set that as a compensation so that it's flat,
right?
And then add headphones on top of that so someone can see, oh, this will relatively to an Eddie-modic have more bass, it'll have a treble, spike here, but something to build, I guess, an application where people can more easily compare, because it's all relative, right? And so if they know what they like, then they can find something that either doesn't deviate from it or deviates from that in the right way.
We could provide the data, but it would be only meaningful. It would be most meaningful if it was done on the exact same system.
Correct.
Right. So then it would be more meaningful. So if it was just like we build a comparator or something like that, where you can take that data and use that as your reference, essentially, invert it and use that as your reference compensation.
Essentially using a compensation that is the frequency response of another headphone.
Yeah, I mean, I guess you could do that. We haven't done that, but it's interesting. So if you're trying to arrive at exactly like an ER4, and you're looking for a headphone that has that characteristic, I mean that could be done. I mean, if you're interested, I mean, I can send you our raw data. We don't have anything like it's not. So we've measured hundreds of headphones, but we haven't pushed it all out. And part of the reason is because I want to have a dialogue with the community. Now, we've been doing this for almost 4 years, and we've been relatively quiet about it because I didn't want to just start. I wanted to learn, because you never stop learning. I mean, my gosh, just at dinner last night with Paul Miller, I learned a lot that I didn't know. I was at a Brulin Care spectrum analysis course 2 weeks ago, and I learned a lot there I didn't previously know. I went to a basic principles of acoustics class from Brulin Care. I thought, it was going to be really elementary, and nope, I learned a lot there. So you never stop learning. So we didn't want to just, at the beginning of this, I'm going to admit it, at the beginning of this, it was kind of like that movie, The Fantastic Voyage, is where they shrunk down the little ship and then went through the body, and then you see all these crazy things in the body and you wonder what they're for. That's kind of how I felt when I was using the audio precision the first time. Because I'm going through, I'm measuring things, and what am I seeing? What does this mean, right? So, so a lot of times if I wasn't sure, I would call AP support and ask them, what am I seeing? What does this mean? Because you're learning. And then, of course, you read a lot as well. And then you just have to do measurements. But we didn't want to put them out at first. And then if you wonder, so we've been doing it for almost 4 years now, why not just dump all the measurements that we've taken and put them out now? Because I don't want to do that. Because I think that becomes part of the problem. And though I think that the measurements, most of them, I mean, maybe some of our earliest measurements would be a bit dodgy. But though they could be meaningful, I want to have a dialogue about measurements more first. Oh, go ahead, another question.
I'm wondering if those measurements really matter for the consumer. So if I, as a consumer, look at two measurements, I mean, maybe, more bass, less bass, and maybe one thing. But on the higher frequencies, I mean, what do those measurements tell me as a consumer? As a consumer, I put the headphones on, and I compare them with other headphones, and I listen to them. And that's the ultimate thing for a consumer.
I agree.
How do they sound? and I don't care about those measurements.
Okay, so I'm more with you than you might realize. So you might say, why do all this? Because so I would rather listen to it as well. So we did a discussion panel in Singapore, and Singapore is Head.F.I.'s biggest city audience in the world. It's a really important community for us, really sophisticated community for personal audio. And they asked me about measurements there, because they said, we noticed you're doing more and more measurements, like you seem to be ramping it up. Well, what do you have to say about that? And I said, what I have to say about it is not everybody lives in Singapore and can listen to this stuff, right? And not everybody works at Head.F.I. HQ and can listen to whatever headphone is out there. And so some people just don't simply have, they don't have the access to the gear to listen to. So independent of the ability to do that, any amount of information, subjective reviews or objective data, can be helpful, right? I mean, independent of the ability to hear it. But if you can hear it, that's always better. Because as we talked about with just that little HD650 experiment, I mean, everybody experiences even each headphone differently. So yeah, you should hear it first. And that's what I said to the guys in Singapore, because they were asking me about it. And I said, I miss the days when the first question after a new headphone was posted wasn't, anybody have measurements? Because that's like the first question that's asked now, and it drives me mad. It's like, I miss the days when we would say, what does it sound like? You know what I mean? And now I think what's happening is people are almost afraid to countermand the data, right? So, I mean, they're influenced by the data. So if you're gonna be influenced by data, at least, understand how the data was generated, how it was made, how that measurement was made. I don't think enough people ask how the measurement was done. So we're trying to show how we do it. Tyler Hertzen showed how he does it. John Atkinson describes how he does it. Brent Butterworth, I know, has talked about it as well. So people talk about how they do it, but you see all these measurements that are just randomly strewn about the web, and we don't ask how they're done. But to answer your question, I would rather listen to it too. So I think that's what we should do. So I had just gotten the Ultrasone Edition 15. I don't think it's out there, unfortunately. It's a really nice headphone from a headphone company I'm not crazy about their headphones in general there's a few models that they make that I really like, and then a lot of them I don't. But they released this Ultrasone Edition 15 that had just arrived like a couple days, I think, before I left. And I said to the guys, I really like the Ultrasone Edition 15, and I have no idea how it measures. So it might measure poorly. I listen to tube amps too. So it's not like everything I listen to measures insanely well. And if you want to hear, by the way, in terms of measurements, the most transparent headphone amplifier, or amplifier period, in the world that I know of right now, it's probably at Benchmark's exhibit, the Benchmark HPA4. That's the hi-fi version of the measurement amp we're using. It has volume controls.
So Sean Olive did a lot of hearing tests.
Yeah.
He had a presentation at the SoCal KJ.
Oh, wait, we have another one.
Oh.
Yeah, Mike. Thanks.
So Sean Olive did a lot of hearing tests, and he did a presentation about that at the SoCal KJ a few months ago.
I think I moderated that panel. Yeah,
you moderated that. And it was quite interesting. He did not talk about measurements at all. It was all hearing tests.
Right.
And he had a graph that I remember. He had the price of the headphones over the quality. And he had like an $80 headphone that was as good as a
I'm trying to remember the specific
headphone.
target. He's pretty measurement focused with respect to his target.
He does the target curve, but not like the nooks and crannies of the high frequencies and all that.
Well, if you remember when they asked him what should we measure?
Yep, but he had like a lot of people just listen to those headphones.
Right.
And that's at the end of the day probably the way to go, and not discussing online if there's like a little blip somewhere at the 5K or 7K level.
Right. No, I agree with you. No, again, I think listening is always the best thing to do. I listen to headphones. There's one I like. It's an old one. Anybody in here been around a while might remember the AKG K340. Probably the most complex, I don't know, maybe unnecessarily complex headphones. Had passive radiators, an electret transducer, and a dynamic driver. And it doesn't measure well. And but I love the way it sounds, because maybe it's nostalgia. I don't know. But I love the way it sounds. I don't care how it measures. But at the same time, again, given that the consumers are demanding measurements, I would like to see the companies provide them. If they don't want to provide them, then work with people like, well, Tyler's retired now, or us, or Brent, who they do trust, who are using standardized methods to do measurements. Because again, they're looking for the measurements. So you may not be looking for them, but a lot of people are. So if you're going to look for the measurements, it's probably better to do them in a way that we understand how they're being done and what they're using and who they are. So now you know how I do it, you know what we're using. But if you don't trust me, that's fine. At least, but you know who's doing it. Yeah.
I cannot read them.
No, understood. So maybe I'm not explaining on that. All right. I'm not sure if there's time for any other questions. Is there any other questions? Oh, 10 minutes. Any other questions, guys? I guess that's it. So if you want to actually see measurements here, I've worked with these guys at Audio Precision. I use their gear. I'm a customer and a partner of theirs. And what suite are you guys in? 3014? 3014. Seriously, you should go up there and see them do audio measurements. If you're interested to see audio measurements being done, I think you guys have a headphone test fixture up there.
Yep.
So they can measure. I don't use their headphone test fixture.
We don't have your chamber, but
Yeah, you don't have. Oh, you don't have a chamber up there.
So we have the South California coefficient in the background.
Okay, gotcha. So there's some Diana Krall compensation. Anyways, yeah, I mean, if you want to see measurements being done of electronics or headphones, you should go up there. It's actually a really interesting thing. Yeah, it's pretty straightforward the way you guys demo it, so you should see it. Thanks anyway for listening, guys. Hope it enjoyed. Thank you so much.
Wait, hold on.
Oh, you got another question? Okay.
Yeah, it's actually not a question for you. You guys have test fixture up there.
yes.
Can we bring our headphones up to get measured right now? Okay, awesome. Thanks.